So good afternoon. This is the course Introduction to Probability Theory and Stochastic Processes. This course is a very famous course in IIT Delhi, not only in IIT Delhi, other institutions. I am teaching this course for last 15 years. The same course is already available in NPTEL other courses also. We are running this course, rerunning. All the doubts you have, you can write down in the chat box so I can answer whatever the questions related to this course. You can write down the chat box. Joined. Next question. Yeah, any sort of questions you can write down in the chat box so that it is easy for me to read and give the comments, give the answer to your questions. Yeah, till any other questions, let me just brief about this course. This course has the very wide applications starting from biology, agriculture, telecommunication, financial mathematics, many more areas. Whenever you have the real world problems which has randomness in it, you are interested to study the such a system changes with the time or randomness or fluctuation and so on, that can be studied using probability theory nicely. Only studied, you can analyze in detail as much as possible based on the probability theory which you use. And also you can do the predictive analysis. What will happen in future, or what if this happens? So those things can be studied nicely based on how you model the real world problem with the nice probability concepts, so that the predictive analysis will be better. If you see my course web, my official website, you will find a lot of research. For that, we introduce the first two-dimensional random variable, then a three-dimension, then any nth dimension random variable. Along with that, we discuss all the joint distributions, cross movements, then conditional distribution, order statistics. So these are all the concepts are needed for the problems which we are going to solve it over the period of time. More you know all the concepts, it is better to make the model. We call it as a stochastic model or probabilistic model. Then we analyze and do the forecasting if needed. And the later part of the probability theory course has a component that is called a stochastic process. So there we discuss only the very elementary level stochastic process, or very introductory level stochastic process, so that you know how to apply some of the stochastic concepts into the real world problem, able to get the solution and do further predictive analysis also. So if you have any questions, let me answer it at this on the screen. Any concepts which the students are asking. Okay. So the question is, what is the connection between statistics and stochastic process? Okay, so all three are well connected in the sense statistics, probability, stochastic. Whenever you see the problem, let me start with the very easy problem, or the current scenario, that is a number of COVID-19 cases at any time. Suppose we want to predict as on today, this many cases in India or in any particular city or in any particular state, how many COVID-19 positive cases in the coming week or in the coming month. So you are interested to the predictive analysis of COVID-19 positive cases. First, we should know how the number of COVID positive cases over the time as on today. Then we should make a nice probabilistic model to do the predictive analysis. Once I say that we should know the information as on today, how many cases, that is nothing but the collection of information that comes from the statistical inference. So you want to infer from the historical data how the number of positive cases are occurring over the days. That means you should start collecting the data, how many cases in every day. You should start analyzing, that is called the statistical analysis, statistical data analysis. Through the statistical analysis, you may be able to get some values to some parameters which will be needed in the probabilistic model. That means one can think of creating a nice probabilistic model. There are many models are available to do such a problems, to solve such a research problems related to the COVID. So the simplest one is the SIR model, and there are many variations over SIR model. So you can think of abstracting the COVID cases with the SIR model or the variations of SIR model. So you conceive some model, it involves some parameters or the rate, for example, the rate in which the number of people get infected per day. Like that, there are many more parameters involved related to the problem which you consider, and that parameter value has to be fixed. So this parameter value, since you don't have the value directly, you can estimate using the historical data. Therefore, the statistics coming to the picture, statistical inference coming to the picture, once you find the value of the parameter values. The parameters are the parameters in the whatever the probabilistic or stochastic model. So once you feed the parameter values, then you can go for using the data, you can estimate the parameter values, then substitute that value in the parameter, then you can analyze, you can predict from that model which you have made it. Then you can wait for some more time, then you can find what is the result which you got it as a prediction and what is the actual scenario happening over the further days. Then you can compare how much error of the predictive model and the real data which is going to come after some time. Then you can improve your model so that the error is minimal. So it's a problem of minimize the error. That is, error is nothing but the difference between the predictive result and the actual data. So you can reduce the error by improving your model. So more you improve your model such a way that your error is reduced, that means your model is doing good fit. The whole, this example which I am explaining to you, that changes over the days. The number of COVID positive cases changes over the days. Therefore, you can map with the sequence of random variables in which each random variable is a number of cases in the nth day or that particular day. And this follows a stochastic process. So using stochastic process and either probabilistic model or stochastic modeling can be able to predict what will be the number of COVID cases in future by as on today with the past historical data. So this is a very simplest example which connects probability, statistics, and stochastic process. Okay. In one of the lectures for week 4, it was mentioned that some of the distributions like F distribution and chi-square distribution are important in statistics, but does not find any application in stochastic process. Please indicate some additional key distinctions between statistics and stochastic process. Okay, good. Thank you. Thank you for asking the question. Yeah, so basically this F distribution, chi-square distribution, and one more distribution that is called T distribution. So these are all the very important three distributions. They are standard distributions. Without these three distribution, you cannot do any statistical inference. That means if you want to estimate the parameters or if you want to find out some sampling distribution, many more things. For everything, you need normal distribution, of course, and then chi-square distribution, F distribution, and the T distribution based on the problem which you are interested. But since our course is probability and stochastic process, we omit these three distribution, but that you can study yourself. Not a big deal, right? Suppose you do the statistics also in your research. That means from the historical data, you are identifying the distribution or estimating the parameters, or you are testing some hypothesis. You make some statement and you want to test. So there are so many things in the statistical inference. For certain things, you may need a certain distribution out of these three distributions. But as far as this course is concerned, we will assume that if at all you need any statistical knowledge that you can pick up from any statistical course. So this course is keeping probability and the stochastic process as important things, not statistics. If I introduce statistics also, then I have to reduce the syllabus of probability, and statistics, stochastic also I have to reduce. And therefore, we keep probability and the stochastic process as a good combination by excluding statistics in this. So that is answer for your first half. Second half is I told what is the connection between probability and stochastic process as much as possible. Yeah, so he is asking one more question. I would like to know if there is a conceptual basis for higher order movements. There is any conceptual basis for higher order movements. For example, expectation or mean provides the indicator of the central of gravity of distribution. Is there something similar that can be applied for higher order movements? It is not clear as what does the higher orders like expectation of expo 3, expectation 4, expectation. Yeah, correct. I got your question. There is no physical interpretation as such. The way you know first order moment is mean and second order moment about the mean is going to be variance, so on. So we can able to label it only first or second, and this of course maybe third and fourth also, not many more. But there is a important concept later you will come to know. More moments exist, or all the moments exist for some certain random variable, then it is easy to predict what could be the distribution. Suppose I have a mean and variance, or sorry, I have a maybe only fifth order moments, 5 moments I have, first, second, third, fourth, and fifth. From there, I cannot able to fix what could be the distribution of this random variable. you can guess or you can make a goodness of it identifying the distribution, but that may be very closer, cannot have an exact one. But more you know the moments, more number of moments you know, you can be able to closer to the actual distribution of that corresponding data. Most of the time, you will end up with the data. From the data, you can be able to conclude what could be the distribution. Means from the data, you make a cumulative numbers, then normalize it. Then you see the graph, how it look like. So then using that CDF graph, can make out what could be the good fit. Good fit means what is the distribution which will map with the CDF of this particular data. So more you have moments, then it is able to do the better fit. If you know all the moments, then using some different concepts, you can able to conclude you know the distribution itself. So actually, there is no name for the moments after few numbers. And now you are asking the cross movements also. So the cross movements does not have much importance. Even the cross movements also in the form of covariance, which we are going to study it later also. So the covariance is again the second order cross movements, or it is a same random variable, then the cross movements is nothing but the variance. So that is also with basically the maximum of two order, second order. So all the further orders of the cross movement, that is very difficult to compute. That is as such, since you are talking about the nth order movement for any random variable, in the same way we give what is the cross movements of ith for the random variable x and jth for the random variable y, and I and j can be any positive integer, but actually it won't play much role in the study. But theoretically, you should know that whether those movements exist or not. That's it, not more than that. CDF properties basically, yes, EAs are asking, should explain what are all the properties for CDF. So any real valued function satisfies certain conditions that will be maybe a CDF of some random variable. And other way, converse, if you have a random variable, the CDF is always exist. And that CDF will have these properties. So it's like if and only if condition. The one condition is very important condition, which when you have a multidimensional random variable, as long as you are able to identify the CDF between some range. If it is a two-dimensional random variable, then CDF evaluated within the some region. If that quantity is going to be greater than or equal to 0, then that is the very strongest condition to make that real valued function with the two variables going to be CDF. That's a stronger condition. And so the CDF will give an idea what type of random variable you have it, whether it is a discrete or continuous or mixed one. That is feasible by seeing the CDF, whether it has the finite discontinuity or countably infinite discontinuity, or there is no discontinuity at all, or it has the combination of both. Accordingly, you can conclude whether it is a discrete type random variable or continuous type random variable or mixed type random variable. Because in the real world, you will come across some random variable has mass at some point, as well as the probability between some interval. There are some random variable which always have a probability which lies between some interval, and there is no or probability 0 at any point. And for some random variable, it may have only mass at some points. Some points it could be finite or it could be countably infinite. So accordingly, you will end up which is going to be a mixed or continuous or discrete type randomly. The simplest example is the waiting time. That is a mixed type random variable because you may have a no waiting with a positive probability, or you have to wait some real, you should wait for some amount of time that has a positive probability. That means it has a positive probability with some interval, as well as there is a positive probability that takes a value, certain value, either zero or whatever it is. Then accordingly he will conclude this random variable as a mixed type random variable, not discrete or not continuous.
Conditional probability.
So the question. I have a question about what is happening in the video. Sir, can you please explain conditional probability with the help of some example? Conditional probability is a scenario in which something already happened and you want to know what is the probability of some event given that something already happened. Whereas the probability of some event that is before something, before nothing happened, you are trying to find out the probability of any sort of events. Whereas the conditional probability means already some partial information you have it, or something already happened in the random experiment. Then you are looking for a probability of some event given something already happened. That is something like simple example is um, yes, before 2020 cricket match started, suppose there are five different countries are playing and so on, and not even the first game is started. So you have all possibilities and all possibilities in your mind. Therefore, you create the sigma field on omega. Then you have a probability measure on omega and F, and you keep asking what's the probability that this team is going to win or this team is going to win. What's the combination of what is the probability of either this or this team is going to win. Like that, you can create n number of events and you can find the probability of. But the game started, T20 match started. Already two matches are over. Now you may not know how many more matches are going to be held because it depends on whatever the rules of the match. So now you are asking, already two matches held. Therefore, what is the probability of some event given these two matches are already takes place and so on. So country won and so on. So score got it and so on. That means already partial information you have it in the random experiment. The random experiment, some of the things already happen. So in that case, it is going to be a conditional probability or conditional distribution. Later, we are going to study the random variable conditional distribution. Not only conditional distribution, later you are going to see conditional expectation. For example, somebody goes to casino with some amount, okay, and start playing one by one game. And some game is losing, some game is gaining, and he's getting some more money, or he's losing some money, and so on. So at some time, he'll end up, okay, at present I have this much money. That may be same as what he bought it at time zero, or it may be more or less. Now the question he himself asked, I played this many games till now. What is the expected amount I will have it after end of the next game, given that I'm having this much money now? I played n minus games, n minus 1 games till now, and these are all the amount I got it. Therefore, at present, I'm having this much money. What is the expected amount I will have it after the end of the game which I am going to play now? That is going to be called it as a conditional expectation. Whatever I'm saying, it is with respect to one random variable. Now we can think of many random variables also. So what is the conditional expectation of one random variable? Given that there are many random variables already got this many values, then what is the conditional expectation of this particular random variable in future? So for everything boils down to understanding of conditional probability concept in a event level. Then from event to random variable is just mapping. Then from one random variable to many random variable is just visualizing for many things happening at the same scenario. So in the same scenario, you can introduce many random variables. Then you can discuss the distribution of those random variables given other distributions are known to you and so on. Then it becomes conditional distribution. I think I would have answered your questions. Another question. Read as many books so that conceptually you will understand the probability and the stochastic process nicely. More you read, more you connect one concept which you read it from one book and another book and another and so on, then you relate everything. Then only you feel okay, you understood this much in this course. Very, very interesting course. More you relate many examples, more you relate many real scenarios, then you'll enjoy the course. Whatever the doubts, you immediately write a mail to us. So me and my TAs who will sit down and understand your question, then we will reply to you as early possible. That's what we are doing as on today. So I thought that this live session will make you to feel good about this course. That is my intention. Whatever the doubts, you keep writing in the whenever you have it, immediately you write down, then we will answer it. People are there. So if no other question, then we'll wind up with this. And whatever the difficulty you have, you can write a mail to us immediately, then we'll resolve it. Fine. It's our duty to do that. If at all any mistake, we will correct it immediately. So you just raise the email, then we'll fix it. Thank you.